Hello. So, can I give away my presentation? I'm gonna do a bit of an intro, a little bit different from I used to. Raise of hands. Anybody knows this name? A few people, yeah. Well, soon is gonna be deprecated, and yeah, so there's gonna be a couple of changes. Like the API, public API, face API myself is gonna change. There's going to be a few, I'm working on a few refactors underneath. um, but yeah, you might not always get the same response from the server. But yeah, it's going to take a bit of time, but basically, yeah, things are changing. And yeah, and talking about things that are changing, last week I joined Just Eat. So yeah. and and it's been amazing. I've been really welcoming and really helpful with everything. And also, I want to also say thank you to Novora as well for organizing Android, and also they've known about my refactor for a little bit while now, and I've been really thankful for all the help. So thank you. And now, yeah, something completely different. So I'm going to be talking about Compose and I'll be a Kotlin. And normally after this you will have an explanation of how the talk is structured. I'm going to say, is it really structured, my talk? Not really. I finished on the way to London from Cornwall. Oh yeah, that's where I live at the moment. So I'm just going to talk about a few things I find interesting about Compose and Kotlin, and hopefully not too many hot topics. So first, I'm going to talk about a little tool I like to make whenever I join projects. I call it fluent type checks. So as you know, in Kotlin, you can do a safe type check. So you can check the type, and then afterwards the compiler knows, well, is this type or not. And I always like to make this little extension function on any type. Don't do it very often. Don't do extensions on any because they can be dangerous because they show always whenever you do it autocomplete. But the good thing about this is that instead of having to do the thing at the bottom, which is kind of the same amount of code, but it looks like there's so many question marks and all that, and it's like, why is it being questioned so much? So yeah, I like to use something like cast as, so it gives you kind of like a nice way to change stuff. For instance, this is another example where you'll be doing like yeah, conditional checks of the type, and it looks a little bit cleaner when you're doing like a chain of operations, basically. This is also quite handy in Compose. See, I'm bringing Compose now. I'm not sure if you've ever come across this in your code, but the reason why the compiler is not happy about this is because of delegation. Delegation means that every time you access a result, it's actually doing a getter, so it's actually getting a new value. So even though we've checked the value, whenever we call result again, that's calling the getter again. So at that point, the compiler is going, well, I don't really know if that's still a success. It could have changed since last time we checked. So one of the things that we can do with this is use the cast as, which means that then you can apply or do things like that. So this is yeah, you're showing the title. If there's a success, if not, we don't do anything, right? Another one I like to do quite similar is the hardcode mode one, which is require. This one, as you can see, there's no question mark. What that means is that if you try to call this and it's not that type, everything burns. So be careful with that one. Another one, types called functions. It's a bit of a mouthful, but everybody knows who knows what a scope function is? Raise your hand. Scope function. Who knows what a let function is? Raise your hand. Oh, I thought there'd be more of them. So basically, there's the scope function is the let, run, apply, also, which kind of gives you a way to jump into the scope of the object that is a receiver. So similar to the casters, we can do things like this. So we can do let as, and what it's going to do is automatically do the check, run the code, and then return the transformation of T to R potentially if it's of that type. So if you remember a second ago, we had this code. So now we can simply do apply as, and then it simplifies your life a little bit because then you don't have to do all the question marks. And it's, I'll tell you, questioning things in your life can take you to interesting places. Now, another similar, we're going, still going with the scope functions. And in this case, I call them conditional scope functions. This one again, let, run, apply also, but then you can pass a condition. In this case I call it when, but you can call it if. You can also make the unless versions. And basically it means is do this whenever the condition passes, right? It's quite straightforward. And you might be thinking, where would you do this? For instance, this is one use case that you might have on your domain, where you might not want to be tracking users' data, ideally, if the user doesn't want to. So don't do that, don't track without permission, please. But more back into Compose, this is quite a handy one if you have conditional modifiers, for example. In this case, it will only run the clickable modifier and attach it whenever the container that we're working with is enabled, basically. Now, how am I running? That's good. Next random topic, async actions. I should have put async functions, maybe, I don't know. Well, basically what this is, actually, let me show you an example. Has anybody done something like this in your code? Yeah? Raise your hand. So you normally, you want to call the scroll state of a list whenever you press a button, for example, to go to the top or to go to a specific item. But this is a suspend function, and you can't really run a suspend function within a callback like that, because you might need to suspend. Yeah, so I was saying, you need a coroutine scope in this case. So the most common thing that people do with something like this, you get the current coroutine scope, and then you launch the operation. In this case, it's an operation related to compose. Don't do this if you're calling the view model, because this scope is very short-lived. It only lives in the current composition. So make sure that if you call in the view model, you call something that's a bit long-lasting. And even if you call some code in the view model and you use the view model scope, if you're doing something that might be long-running, like deleting stuff, make sure you find a scope that lasts a bit longer than the view model, because otherwise when the user exits the screen, everything goes away. But anyway, going back to local scopes in Compose, one little tool I like to do is this one, called it run async. I'm basically doing the same code that we're doing before, but in a shorthand. And also, HOF is not related to Baywatch. Is a high order function. What it means is a function that returns another function. So in this case, we can say anything that's suspended here, we're going to convert into a function that we can run naturally. The inconvenient thing of this is that every time that we use it, we create a new scope, but it's pretty cheap to create these scopes. And again, don't optimize unless you need to optimize, right? If it makes your code nicer to read, I think it's a higher benefit than having something performant. So then, yeah, it looks something like this, and it's nice and tight. Yeah. The other thing I was going to say is that sometimes you might have situations where you can't just provide a I forgot what the name is when you have no parameters, but basically you can't, you need to consume a parameter. So then you can create things like consumer sync, in which case you have like 1 or 2 values, and then as many as you need, but hopefully you don't have more than 2 or 3. Now, next random topic, magic numbers. Who knows what a magic number is? Good. So what are they? I've had different definitions, but basically what it means is a value that is defined and hard coded in the code, but without an explanation of what it is, right? So it's magical. It's also used in other fields with different meanings, but that's what we mean. So you do have something like this, and it's like, say that service, it's like, true what? 1 what? 10,000 of what? So you don't know what's doing here, right? So the most common thing to do is to have constants like this, right? Who's done code like that before? Raise your hands. Oh, come on. Everybody must have done it. So the thing with magic numbers is that often people forget why we do them. And I've seen this in a piece of code. That's the word, yeah, code. I've seen this before. And it's like, what? I mean, sure, that follows the pattern of not having magic numbers, but that doesn't really add any value, right? And it's not very often that you're going to need to change that value, hopefully, unless you're doing some weird quantic maths, I don't know. And also, why are we yelling? Why are we having uppercase? Like, the original reason why we do uppercase is because IDEs were not very good. So it was a way to signal. It's kind of like back in the day, people used to use M prefixes or S prefixes to know if it's a member variable, a static variable. So similarly, it's kind of like a type of Hungarian notation, right? And actually, if you're using compose, the actual guideline says to use podcast case instead of screaming case. I would always recommend to use this. There's several reasons, because also more importantly, to if you're doing enums, for example, normally in Java enums had also screaming case, but suddenly if you can change an enum to a CL hierarchy like a CL class or CL interfaces, now you have to rename your whole code. So just use Pascal case. Like there's no real good reason to still use screaming case other than it feels cozy. And going back to the topic of magic numbers, we have another thing in in Kotlin, which is name parameters. You don't need to have an extraction of that because it's clear. It's an auto start, true. However, if you have control of the setup service, I would recommend go further and have something like this. So have types. Don't use primitives because primitives are ambiguous. If you suddenly need to add another property for start strategy, it's a lot easier to add an extra one. And it's a lot more clear to pass data. Also, going back, actually I forgot about this. Since both current forks and fork timeout are ints, if you don't pass the name parameter and you had it like this, it's actually relatively easy to get them upside down, like the wrong order, and you don't have any way to know. So if we go back to, whoops, that one, try to use actual discrete types. It will help your code. It will explain things better to somebody else that's going to maintain the code. And that's enough of magic numbers. Let's talk about talk about something a bit different, which is just doing nothing. It's kind of similar to magic numbers, but have anybody, get your hands ready, done this when you have an empty case? Raise your hands. So this is a magic number because you don't know why that's empty. If it was a return null, you don't know why it's returning null. So it's still a magic number. It's not a number, but it has the same principle, right? So I normally like to declare something like this, which is a throwaway function that you can call do nothing, and it does what it says, nothing. um, and then in your code, you can say, well, we're not doing anything here because we don't want to show more than 6 items in the list. So then the next person comes and goes, oh, so that's why this is empty. So you get some context. Also, if you want to return a default value or a null, you could have something like this. Provide value because this or that, or provide a null because of that. And that would make your code a bit more easy to reason, I think. And again, because it's in line, it would add a little bit of compilation time because, although minute, probably milliseconds, because it has to remove it from the code. But it adds context to your code, which is always important, right? And now, another random topic, result box. So there is a problem in UI, which is we don't expect 2 things, or we don't plan for 2 things, and we should always plan for lag, loading time. It doesn't matter where your data is coming from, if it's from the database, from the server, from next room, like always expect lag and always expect failure. These are the 2 things that whenever you're doing a UI, if your designers don't have loading and failure state, go back to them and say, please, can I have some? And when I say always, always. I live in Cornwall and the internet is limited. And I've seen a lot of apps, including Android itself, where you click something and nothing happens, and eventually goes, oh yeah, I'm here. And it's like frustrating to the next level. So the simplest way to make sure that that we're handling these errors is this. I know it looks scary, right? It's a result, so it could be an exception, it could be a result, it could be a nullable. But this gives you everything you need, really. Like, it gives you null when it's loading, an error as a throwable. I know having throwables as an error is being taught to us as sacrilegious, but it works. I mean, and I said result box because having something like that, it's fairly straightforward to set up something like this in your project so that everybody has a loading state and an error box. And it's customizable, you can have your own ones, but it means that you can, you have more, what do you call it? Everything is expected as it should be across the app. You can also do this. I mean, if you have the classic loading success failure in like, who has something like this in their code base? Well, raise your hand. Come on, someone has it. So it's very common to have this, and similarly you can do it. It goes a bit different. It doesn't have fold because, although you can create your fold if you want. But it does the same thing, and this is quite good because then you can have, that's the word, consistency. So you can have more consistency across your UI, and you're always going to have some loading and error states, or it's going to force you to have these things. Now, I mentioned errors, and another one, this is, I didn't want to get into hot topics, but this is, I guess, a hot topic. It's quite common to define hierarchies of errors like these, right? Again, I'm going to ask, who has something like this on the code base? Yes, yes. The thing is that this is really well intended and it's great because you have types and it doesn't have, they're not as costly as exceptions and all that. However, you always get that at the end, right? Because you never know. It's always going to happen that you don't know what happened. So you always have an unknown. It's life is like that. I think there's a repeated one. No? Oh yeah, sorry. So since we're going to do this anyway at the end, why not do that? Does it feel cringy? We've been taught that using exceptions is bad, but is it? I mean, you have to do things like this because the thing with objects in Kotlin is that when you try to serialize them back, it doesn't always find it. I'm not sure they fixed it, but anyway, you have to make sure that when it resolves it, it goes to the same instance and all that. And if your team says, "Oh, but exceptions are too expensive," and like because they're really heavy, just stick that at the top, and then it's not gonna, because these are types that you're always gonna handle, right? Like you're not gonna need the stack trace, especially if you use them in known places. So you don't need, you're not gonna need the stack trace. So you use that. And with that bad hot take thing, also just one last thing. This week is this, so give some love to transposal non-binary that you know, and yeah, that's it.